Here is the first lecture of chemistry, mole concept. Mole. Mole is just a number, and 1 mole is equals to Na particles. Here Na is Avogadro's number, and it is a symbol of Avogadro's number. Here the value of Avogadro's number is 6.02 multiply 10 to the power 23, which can also be written as 6 multiply 10 power 23. It is often used in numericals to simplify calculations. Here particles includes molecules in substance, atoms in element, electron, protons in also neutrons in atom, and ions in ionic compounds. Here are some fundamental particles: electron, protons, neutron. Their mass and charge values are important for calculations in numericals. Here the mass of electron is 9.1, 10 power minus 31 kg, and the charge on it is minus 1.6 multiply 10 power minus 19 coulomb, and proton mass is 1.672 multiply 10 power minus 27 kg, and charge on proton is plus 1.6 multiply 10 power minus 19 coulomb, and mass of neutron is 1.674 multiply 10 power minus 27 kg. And as you know, the charge on neutron is 0. Here the mass of electron is less than proton, and the proton mass is less than neutron, and maximum mass in fundamental particles is neutron. And here the charge comparison between electron proton. The charge on electron is equals to charge on proton, just difference is in signs. Electron contain negative charge and proton contain positive charge. And then we discuss the term molar volume. Molar volume is defined as the volume of 1 mole of any gas at STP. STP means standard temperature and pressure. The value of molar volume at STP is 22.4 liter or 22,400 ml. The at standard temperature and pressure, the value of temperature is 0 degrees Celsius or 273 Kelvin, and the pressure is 1 atm. The value of molar volume is changed with temperature and pressure. Before we discuss the calculations of mole, we will discuss the terms of mass. Then we will discuss more calculations of mole, and that will be easy for us. There are 7 terms of mass in chemistry. Average atomic mass. Average atomic mass is according to the relative abundance of isotopes. For example, chlorine. Chlorine contains 2 isotopes. Chlorine 35, its relative abundance is 75%, and chlorine 37 with relative abundance 25%. Now we will calculate average atomic mass by multiplying atomic mass multiply relative abundance plus atomic mass of second one multiply relative abundance of second isotope, and then we plus both of atomic masses relative abundance. The answer will be 35.5. And one point in this is average atomic mass is always closer to that isotope where which relative percentage is more. Let's make an example. The relative abundance of chlorine 35 is 75%, which is about 1/3. So that the average atomic mass is 35.5. That is much more closer to chlorine 35. And now we will discuss atomic mass. Unit in this is AMU, and we will define as mass of one atom in element, such as hydrogen 1 AMU or lithium 7 AMU. And then molecular mass is mass of one molecule in a substance. Like H2O is 18 AMU, or glucose is 180 AMU. And now we will discuss gram atomic mass. Gram atomic mass unit is grams, and it is defined as mass of 1 mole of atom in an element. Here is hydrogen is equals to 1 gram, or lithium equals to 7 gram. It's just like atomic mass, but unit are different. Gram molecular mass. Gram molecular mass is just like same as molecular mass. It is mass of 1 mole of molecule in a substance. One mole of molecules is equals to any molecule. H2O 18 gram, and glucose is 180 gram. And now we will discuss formula mass, and it's the mass of 1 mole of formula units ions in ionic compounds, just like NaCl, which is equals to Na23, and chlorine is 35.5, 57.5 gram. If we combine all the atomic mass, gram, molecular mass, formula mass in a one term, it's a molar mass. Molar mass is defined as mass of 1 mole of substance. It may be Na, that is 23 gram, or H2O, which is equals to 18 gram, etc. These are the terms of mass used in chemistry. Hopefully you will understand. And these are the terms. If we want to find the percent composition of any element, here is the formula. Pub is weight of an element divided by molecular weight and then multiplied by 100. For example, H2O, we will find the percentage composition of hydrogen. Here is the weight of an element. Weight of an element is 2, and molar weight of whole compound is 18. Multiply 100. We will solve it, and answer of percentage composition of hydrogen in H2O. And then the vapor density. Vapor density is relative density to hydrogen. Vapor density can be calculated by molar mass of all the substance, any substance divided by 2. Now we start the calculations of mole. If the weight of a substance is given, then we find mole by using formula number of mole is equals to given weight divided by molar mass. And if we find weight, number of moles multiply molar mass. And if we find mole by using particles, and moles is equals to given number of particles divided by Na Avogadro's number, which value is 6 multiplied 10 power 23. And if we find particles by using moles, formula is particles is equals to moles multiply Avogadro's number. And if we find moles by using volume, molar volume, which is given volume divided by Vm molar volume, which value is 22.4 liter or 22,400 milliliter. And if we find given volume, then we multiply number of moles by with molar volume. If we find mole by using weight, we will divide. But if we find weight by using mole, multiply. Same in the case this. If we find moles, then we divide, just like this. If we find particles, we will multiply. And same in the case here. But in volume, there are a few exceptions. It only applicable on gases or at STP. Now there is a second last term in concept of moles topic, stoichiometry. Stoichiometry is defined as simple way is balance the reaction. In these two cases are given. First case is when information about only one reactant and product is given. Just like it's a general equation, just like that H2 plus O2 H2O. We balance it by 2. In this, if the mass of hydrogen is given, just like for example 4 grams, we will find the mass of water by comparing the H2 and water. First of all, we balance the equation by simple way, balance it later. Firstly, we calculate the moles of hydrogen. N equals to 4 by 2, that is 2, and then we compare hydrogen with H2O because it's given, and we find this. In balanced chemical equation, 2 number of moles of hydrogen gives 2 moles of water. Simplified, the given number of moles of hydrogen is 2, then again 2. 2 moles of water is produced when 4 grams of hydrogen is used in this reaction. So we find the mass of water by number of moles multiplied by molar mass. Number of moles is 2, molar mass is 18, so the mass of the water is 32 grams. In the second case, when the information of 2 reactants or more than 2 reactants is given, then the concept of limiting reagent is introduced. Limiting reagent is consumed early, is the reactant which is consumed early in the reactions. The formula of this can be found by using this simple formula: given amount of reagent given amount of reactant divided by stoichiometric amount of that reactant. Here is the example. it's 2 gram, it's 4 gram. We find the mass of it. We will compare by using the limiting reactant, because two reactant information is given in this. We using this formula. Given amount of reactant is in hydrogen is 2, divided by stoichiometric amount of that reactant. Stoichiometric is balanced equations. Balance, first of all we balance it, and then it's 4 divided by 4. Stoichiometric amount we calculate it, the mass is 4, then we find the answer is 2. But in case of oxygen, 4 divided 32. Stoichiometric amount mass saving. The mass we will return the mass. We calculate it, which is 2, 6. It's 2 by 6, which is very much less than hydrogen. By using this formula, the oxygen value is less than hydrogen, so limiting reactant is oxygen. So to find the mass of the water, we firstly calculate the moles of oxygen. It's 4 gram given, divided by molar mass 32, it's 2 over 16, it's also equals to 2 over 8 moles. Then compare O2 with H2O, because oxygen is limiting reactant. In balanced chemical equation, its mole is 1, its mole is 2, but given mole is 1 by 8, 1 by 8 multiply here 1 by 8. We found the moles of water is 1 by 4 by calculating this. So the mass of water formula is number of moles multiplied by molar mass. Number of moles is 1 by 4 multiplied molar mass 18. We found, by calculating this, we found 4.5 grams. 5 grams by, so the answer is 4.5 grams by calculating this. In this way we can calculate every type of questions by using stoichiometry, limiting reactant, and in this case we find mass of water and mass are given, but we can also find mass to volume, mass to moles, mass to mass, and also mass by mass. It also be reversible. When the mass of the product is given, we can calculate the mass of the reactant by comparing just by this way. In the lecture we will discuss the concentration terms. These are used in solutions, but in the mole concept it is used in numericals, so we will understand them. Concentration terms is divided into two parts: temperature dependent and temperature independent. Temperature dependent are percentage volume by volume, percentage weight by volume, and molarity. First of all is percentage volume by volume. It is defined as the volume of a solute in ml present in 100 ml of solution. The formula of this one is percentage volume by volume is equals to the volume of the solute in ml divided by volume of solution in ml. Multiply by 100. And the second one is weight by volume. It is defined as weight of the solute in grams present in 100 ml of solution. The formula is percentage weight by volume is equals to weight of solute in gram divided by volume of solution in ml multiply 100. And then molarity is the amount of substance in certain volume of solution. Molarity symbol is capital M. Its formula is M is equals to moles solute divided by volume of solution in liters. Another formula is molarity is equals to number of moles of solute divided by volume of solution in milliliter multiply 100. And then the temperature independent terms are weight by weight, mole fraction, molality, and parts per million. First of all is weight per weight. Percentage weight by weight is equals to weight of solute in gram multiply 100 divided by weight of solution in grams. And then the mole fraction. Mole fraction is the ratio between moles. Explain mole fraction a little bit. The formula is mole x, the symbol of mole fraction, is equals to n substance, number of moles of substance divided by total number of moles. In solution there are two substances, one is solute and second one is solvent. If we find the mole fraction of solute, then XA is equals to number of mole of B divided by number of mole of A plus number of B. And if we find the mole fraction of B, then XB is equals to NB divided by NA plus NB. If we plus both XA, XB, then the answer will always be unity. Then the parts per million. Parts per million, we only remember the formula of it, that is weight of the solute divided by weight of the solution multiplied by 10 power 6, that value of million. Then the last one is molality. Molality is the total moles of solute in kg of solvent. The symbol of molality is small m. Its formula is m equal to number of moles of solute divided by weight of solvent in kg, or m equal to number of moles of solute multiplied by 100 divided by weight of solvent in grams. Subscribe my channel and also follow my Instagram page, link is in bio.